Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, meet again with building structural system 1. In this opportunity I would like to discuss about the relationship between form and structural efficiency. As you know that in architectural concept we always talk about form and its efficiency, either in a sense of function or in the sense of the form itself. So what about the form that has correlation between structural system, or the behavior of the element that affected to the structural system itself? So in this opportunity, let's talk about this relationship. First of all, I would like to talk about the internal stress. As we know here that the internal stress are divided by the axial and the bending type of load. The axial load, actually the load that working in the axis, in the x of the element itself, either this element columns or the beam. But the axial, the most important understanding about the axial load is that this load is only working on the line in the center of the elements. In other hand, if we have bending, this load is working not in the line of the element but perpendicular to this element. No matter that the magnitude of this axial or bending can be compressive or compression to tensile or tension stress. The next step, we have to know about the differences between axial, eccentric and torsional load. In the first drawing we have axial load, but if the load line itself doesn't perpendicular to the element, we have the eccentric load. And if the load itself is perpendicular to the element, it's called torsional load. The next is the basic relationship between load and structural elements. As we know that the load coincident with the principal axis or axial force. If the load is perpendicular to the principal axis, it's called bending force. But in between, we have load inclined to the principal axis. It's combination of these two between A, axial force, and B, bending force. So in the building, we'll have this kind of combination load in some part of the building. Let's see. For example, at this building, we have inclined column. This inclined column recently have or gain a success in their popularity to be used or utilized in some building in order to make the building more dynamic, attractive. We may use this kind of inclined column. This inclined column, of course, architect will have the opportunity to make different style of, let's say, conventional building with this inclined column. So either external or interior of the buildings, we may find such kind of difference aesthetic of the buildings. The next is what we call form active shapes. Next discussion about these form active shapes actually have strong relation with the funicular structure that we have discussed in the previous video. If we have this tensile form active shape, and then we may found exactly the same form but in the opposite direction. We call this as funicular form or funicular structural system. If in tensile form, we will have this kind of shape. In the opposite way, we will have this compressive form active shape that came from purely compression on the bottom and tension on the up. So from this behavior of the element, we may create or we may make a concept from this behavior, the way the form according to the load create the shape for themselves. The example of this form active, we might find cell building. This active cell building can be used effectively to transform the load according to the shape of the buildings, or the shape of the building can transform the load effectively. The other example of active form is cable structure, either for the bridge in this way or for the buildings or stadium in this way and other way. We may find that many configuration of cable structure can be used for certain function. The next example from form active is an arch. From previous video, we found that this arch was actually the original wide span structure from masonry materials. So this arch, this form of the arch is the most effective way to transform the load above the arch itself, to transform the load from above to the earth. And also we can use other type. There are many type of arch that you may find to transform the load to the earth itself. The next is that this relationship between element shape, load pattern and element type can be non-form active bending. Actually, this common in the buildings, especially for the modern building, since they are not using arches. So this non-form active bending, it's common for column and beam structural system, let's say. But form active actually can be used more efficient in the way to transform the load and the reaction of the element of the buildings. But we also find that we call semi-form active. That is a combination between non-form active and form active. In some building, we may find this kind of arrangement between the place of the load and the form of the system of the building itself not exactly fit between the loads themselves and the point that they have to support the load, such as in the connection of the member or in the corner on the joint of the elements of the buildings, like B samples. This is my use in the element of the buildings that we call semi-form active. And then we are going to the deep of the inside of the elements of the building itself. The effect of cross-section shape on the efficiency of elements. If we have the beam, for example, massive beam or concrete, let's say, this concrete have high bending stress that occurs at the outside fiber only. So that's why we call it, this is the way the load transform inefficiently used, because these loads only happen in the envelope of the beam. So this is different with the case of using steel profile, for example, or hollow steel. In this case, both profile, I profile or H profile or O profile or hollow, the efficiency is increased by elimination and stress material in the center of the cross section. So since the load itself only happen in the skin of the element, this profile elements will work more efficient rather than massive elements such as concrete beam. If we talk about the concrete, they don't have this form of the profile, but still have this many shape for their profile. So according to this shape, and then the load can be transformed accordingly. So we might choose which one appropriate for certain of the load that will happen in the elements. The next is the effect of cross-sectional shape on the efficiency. If we have thin layer and then we put on the base like this thin layer will inefficient to support even for itself weight. But if we make folded like the second picture in the middle, and then this folded layer will give efficient cross section. Can we use the other form instead of folded layer like this? Of course, if we don't want to make or to use folded layer, and then we have to make more thickness in the layer. So this thickness is enough in order to make this span bending. But of course we have to consider about the mass of this massive element. So the advantage of using folded layer, this element will be very light, but this element will be very heavy. So that's why the folded plates for the floor, for example, it's more efficient if we are using this kind of folded plates. The next is the efficiency of non-form active elements. If we have this kind of arrangement between load and two bases, one load, center load, the other one is load of the element itself, or the load that not only happen in one point, but in average we may find that the diagram of the load itself, it's like this. This is diagram, moment diagrams. Actually, from this moment diagram we can find directly the most efficient shape of the profile. What I mean, if we have this kind of arrangement between load, either center or pointed load and average load like this, and then the element itself can be profile or cutted profile like this, exactly like the diagram itself. The other efficiency, for example, for the steel profile, we may use these holes of the element, because this hole actually needed in order to make lightweight the element itself, since the existence of the part is less used, or it will not bear any loads or less load. So we may take some part of unused element to be this kind of profile. So these holes are actually not in the purpose of the aesthetic aims, but more in the efficiency of the material itself. The next is the efficiency of form active elements. As we know that the trusses will very effective if they are using the triangle shape for their elements, because this triangle resists by axial internal forces in the element itself. But if we are using other shape rather than triangle, the use of this shape, for example rectangle or other shape, it cannot resist by the member internal forces itself, since the load will not effectively in the member, or let's say the axial force, but it might be create another perpendicular forces. So the shape other than triangle is not suggested to make part of trusses. The other efficiency of form active element we may find in a solid beam and the trusses. We may compare between solid and truss, and also the truss that bear the load not in the joint. From these three drawing, we may find that the solid beam is less strong and rigid than a triangulated structure of the same weight. The axial internal force only condition does not occur if load is applied to a triangle structure other than its joint by in this way. So the best way to put the load is in the joint. Otherwise, it will create this less efficient, like a single beam happen in the truss. So this is not suggested, since it creates the bending of the element. We have to remember that the purpose of the element of the truss is not applying the bending or center load other than the joint. The trusses itself, we may find that we can create many of shapes of the trusses according to the shape of the building itself, or according to the interior of the buildings. We may find from the simple one to complicated one, but most of them are formed by the triangle. And then we may find as well a classification of structural element. The least efficient shapes, which is non-form active element, can be seen on the massive element, let's say concrete beam, columns, and plats or slab. But we can create this massive element more efficient by applying the folded slab, for example, like floor, in this way by concrete, or in this way by steel. And the next step, in order to make more efficient, and then we are using the combination of the member that we call as truss. This truss can be either 2-dimension or 3 dimensions. The next step, if we want to make more efficient, then we come to semi-form active element, which use single element according to the load itself. But this single element again can be replaced by the truss. So this truss can be used instead of single element in order to make more efficient shape. And the last is, of course, active from tensile. So this tensile active element can be seen as the most efficient way to make a building, since we are only using minimal materials. Cable, for example, if we combine this cable with the single element such as column and beam, of course the size of the material of this tensile structural system is less. So this way this tensile structure can be seen as the most efficient shape of the structural system. And the next is the matter of column or beam. So from previous explanation, we may understand that if we have the load is being transferred primarily by the load that working in the axis, we may have a column, but of course this load will work as a compression. But in the opposite way, if we have tension loads working on this element, and then we will have tie. This is tie, this is column, since we have compression on the column, and we will have tension on the T. But if this load not in the axis but perpendicular to the axis, and then we'll have beam. Most of beam will work like this. That's why beam will easily have bending and moment as well. So the load transfer on the bending way we called beam. And this beam can be vertical beam as well if we applying lateral forces, for example. So this column can be act or can be function as a beam as well. So in the complete structural system, we may conclude that this material of column and beam, and then put the layer of slab, we may find the complete structural system such as this building, for example. This slab can be roof on the top and can be floor in between, and can be foundation if we put on the basement. So this horizontal element between column and slab combined with the vertical column between a vertical element between column and walls, and also we will have 3D wall that we call core. For some high-rise building, for example, we will have this kind of core structural system, but this core structural system is a form of column and wall that work in 3D way. So this kind of column and beam combination may configure the complete system of structural system. So you might check the references from McDonald, Structural and Architecture, and also some website. There are many sources from the website that we can learn about the structural system and the element related with the form. So that's all for today. Hopefully we may little bit more understand about the form and their properties in order to able to talk about the part of architectural concepts for our buildings. Assalamualaikum warahmatullahi wabarakatuh.